Hi, this is Mrs. Jackson. This is Chapter 3, Section 2, Part 2. In this quick video, we're going to review how to multiply polynomials together and find their product. I have 3 examples here. The first one is a binomial multiplied by a trinomial. You may have used a box method in the past in Algebra 1. If not, I'll show you how to do that here. It's really just a graphic organizer to help manage all of the distribution. In class, however, I will predominantly just use horizontal multiplication. Okay, so let's get started. So the first example here, remember everything has to distribute to each other. So I usually kind of draw these little arcs just to remind myself that everything's got to distribute. So the 3x times negative 2x squared is going to give you negative 6x cubed. The 3x times positive 6x is going to give you 18x squared. And then 3x times a negative 1 is going to give you negative 3x. And then the negative 4 distributing is going to give you positive 8x squared and negative 24x and then positive 4. So you look for like terms. The first and highest exponent is the negative 6x cubed, and there's nothing to combine that with, so we're going to leave that as is. And then next we have our x squared terms, so we have 18x squared and 8x squared, so that's going to give us 26x squared. And then we have negative 3x and negative 24x, so that's going to give us negative 27x. And finally, we have one constant, which is the positive 4. So the resulting product in standard form is negative 6x cubed plus 26x squared minus 27x plus 4. All right, so I did want to quick show you the box method if you haven't seen that before. You set up a box in any orientation you want. I've already set one up here. And you take your binomial, since there's 2 columns, I'm going to put my binomial term here. And normally I put the other terms on the left-hand side, but I've kind of smushed my numbers in there. So I'll just go ahead and put it over here on the left-hand side. So you get the negative 2x squared, 6x, and a negative 1. And the box is really just managing that you all of the distribution, that you don't forget a term. So you start to do your multiplication as you normally would, and you'll get all your terms lined up. And then you would just combine each of the like terms. And you can see here that the like terms with the box method, they fall on the diagonals. So you can see which terms are like terms that would need to be combined. But anyway, if that technique helps you, you can certainly use it. The next example is quite a bit more rigorous, mainly because there's 3 binomials to multiply together and there's 2 variables. So paying attention to exponents is important, and managing that distribution is also really important. What I usually do is I take that first binomial and I just leave it alone. I just rewrite it. And then I do the distribution between the last 2 binomials. And I take care of that first binomial last. So now if I multiply these 2 together, the first term I'm going to get is I'm going to end up with 3 m's. So I've got m cubed and 3 n's. Then I have 2 times m squared n. Now it's the negative 1's term, so I'm going to end up with negative m n squared and negative 2. And so now we have 4 terms, 4-term polynomial. So the distribution with that and a binomial gets really kind of unwieldy. You definitely have to manage somehow organizing your work. Otherwise, you can easily drop a term. All right, mn, I'm going to start with this term here, and then I'm going to distribute it to every single term over here in the polynomial. So I get 4m's, 4n's, plus 2m cubed n squared, minus m squared n cubed, minus 2mn. Now it's the positive ones term, and I'm going to move over just a little bit here. Okay, so I have plus m cubed n cubed plus 2m squared n plus, I'm sorry, that is not a plus, that is a minus. I've got minus m n squared minus 2. Okay, I think I have all my terms now, and we're going to look to see where are like terms by inspecting all of the variables combination and the exponents. So this first term, it's got an m to the fourth and an n to the fourth. If I gaze across here, there's no other term to combine with it. The next term has an m cubed and an n squared. So I'm looking for that combination across here, and I don't see it. The next term is m squared n cubed, and there are none. Just mn with no exponent, and there is none. Both are cubed, none. M squared n, mn squared. So if you really inspect these variables and exponents carefully, you can see there are actually no common terms here that we can combine. So now let's focus on how to put in standard form. To do that, we're going to look at the sum of the exponents. So this first one is an 8. I'm just going to write it above it to help me organize my work. 5, 5, we get a 2, we get a 6, a 3, and a 0. So we're going to go in descending order of the sum of the exponents. So we have an 8, and then we have a 6 and 2 5s. So we're going to first go with that 8, m to the fourth, n to the fourth, and we have a 6, so that's going to be next. And as I'm doing this, I really should be crossing these out so that I don't lose track of a term. Next we have 2 5s, and we have to look to see which one's going to go first, and the alphabet dictates m before n, so we are going to go and defer to the highest exponent on the m. And so we'll write the next one here and cross them out. And what do we have next? We have 2 3s, and we're going to defer to the m. So that would put the m squared first. And then we have 1 2 and 1 constant, minus 2. So that is the product of these 3 binomials, and it takes a lot of careful work to make sure that you don't drop a term and that you get all the exponents correct. All right, let's go with our last example. We have a binomial, 5x minus 2, and it is raised to a power of 3. This is what we have a term for this, and we call it binomial expansion. So I think I'm going to write that down. We do have a section in this chapter on binomial expansion, but we may not do it given the schedule. So I'm going to write this down, and we're going to write it out long here. So we have 5x minus 2 times 5x minus 2 times 5x minus 2. And as I did above, I usually just leave that first one alone, and then I go ahead and start doing my distribution on the last two. So I have 25x squared minus 10x. Now it's negative 2's turn, so I end up with a negative 10x plus 4. And I go ahead and combine these like terms here. So I've got 25x squared minus 20x plus 4. And now I start to distribute with that last binomial. So I end up with 125x cubed minus 100x squared plus 20x. Now it's the negative 2's turn, minus 50x squared plus 40x minus 8. And now I start to combine like terms. My 125x cubed has no other like term, but I do have negative 100x squared and negative 50x squared. So I could combine those two. And I do have positive 20x and positive 40x. And then I just have my constant. One of the things, if we don't get to it, there is a theorem that we can use to do binomial expansion. And it basically teaches you how to just look at these numbers and then look at the power and figure out what the coefficients are without going through all of the distribution. It's kind of a neat theorem when you look at the derivation of it. Okay, so in this video, we reviewed how to multiply polynomials together, and I hope this video helps. Thanks for listening. Please subscribe.